Hello student, how are you? Student, today I will tell you what is argument of any complex number and how we can find it. Student, in my previous lecture I have tell you about what is complex number, what is ordered pair of any complex number, what is modulus of complex number and how we can find the modulus of any complex number. If you don't know these things, then you can go to my channel and can see the videos. Student, today I will tell you about what is argument of any complex number. Very first I will tell you the definition of argument of any complex number. So definition is angle made by complex number from positive real x-axis is known as argument of any complex number. So here I am taking base positive real x-axis. Why I am taking base positive real x-axis? Because as we know that there are two axes in complex plane. One axis represent real part of complex number and another axis represent imaginary part of complex number. Positive x-axis represent real part of complex number and y-axis represent imaginary part of complex number. So here I am taking base positive x-axis. So here I have taken four situation and I have taken four quadrant. In all four quadrant we will see how any complex number is making angle with positive x-axis and what will be the argument of complex number in any particular quadrant. Okay, so here in first situation I have taken complex number in first quadrant. Let this is point P, this is representing complex number a plus ib. So if I will join this OP, so OP will be the modulus of this complex number. So this angle theta will be the argument of this complex number if it is in first quadrant. If complex number is in second quadrant, so this angle will be the argument of complex number if this complex number is in second quadrant. If complex number in third quadrant, this angle will be the argument of complex number if this complex number is in third quadrant. If complex number is in fourth quadrant, so this much angle will be the argument of this complex number if complex number is in fourth quadrant. So this was all about the argument of complex number. I want to tell you one thing. Here I am drawing complex plane. Let this is positive x-axis, this is y-axis. This x-axis is representing real part of complex number and this y-axis is representing imaginary part of complex number. Let this is point P and this is representing complex number a plus ib. Let this is origin. If we join OP, so OP will be the modulus of this complex number. Let this is angle theta. So value of theta will be argument of this complex number if this complex number is in first quadrant. So student, tell me one thing. If this OP turns anti-clockwise like this and complete one round and reaches its initial point, so in that case angle made by OP from positive real x-axis will be theta plus 2 pi, because this complete second round and reaches up to its initial point. So in that case angle made by OP from positive x-axis will be theta plus 2 pi plus 2 pi is equal to theta plus 4 pi. So student, here you are seeing that if OP complete one round so and reaches up to its initial point, so in that case angle made by OP from positive x-axis is theta plus 2 pi, and if OP complete two round and reaches its initial point, in that case angle made by OP from positive x-axis is theta plus 4 pi. So here problem is that what value should be taken as principal value of this theta, because here we will get infinite value of theta because OP can complete infinite round, and in that case OP will make infinite angle from positive x-axis. So problem is what value should be taken as principal value of theta. So here one thing is suggested that value of theta will be greater than minus pi and will be less than or equal to pi. So we will take the principal value of theta in the interval of minus pi to pi. Value of theta will be greater than minus pi and will equal to or less than to plus pi. Okay student, now student, if you don't know what is minus pi and plus pi, so see here, let this is x-axis and this is y-axis. So student, let this is point P, which is representing a plus ib complex number. Let this is point P. So if we measure angle, so if we take angle clockwise, then in that case angle will be negative, and if we measure angle anti-clockwise, then in that case angle will be positive. So this is minus pi. So minus pi is what? If we starting from here and we are going like this. So if we going like this and reaches here, so this will represent minus pi, and if we are starting from here and going like this, so this will represent plus pi. Okay, so this will be the interval. Now student, I will take the example, and from the help of example I will try to explain what will be the argument of any complex number. Let z is equal to 1 plus I. This is complex number. I want to know what is the argument of this complex number. So in which quadrant this complex number will lie? Tell me. Here value of a and b are positive, value of x and y are positive, so it means that this complex number will lie in first quadrant. Okay, so we will draw this. Let this is x-axis, this is y-axis, let this is point P, that is representing 1 plus I, and this is angle theta. So we have to find the value of theta. So what will be value of theta? Here value of theta will be find by a formula, and formula is theta is equal to tan inverse mod of b upon a. This is the formula for finding the argument of any complex number. If any complex number is in first quadrant, then value of theta will be tan inverse b upon a, and if any complex number is in second quadrant, then value of theta will be pi minus tan inverse mod of b upon a. If any complex number is in third quadrant, then value of theta will be minus pi plus tan inverse mod of b upon a, and theta is fourth quadrant, then theta will be minus tan inverse mod of b upon a. So this is the formula. Here complex number is in first quadrant, then theta will be tan inverse b upon a. So what will be the value of a? Here value of a is equal to 1 and value of b is equal to 1. So theta will be tan inverse 1 upon 1. So theta will be tan inverse 1. And what is value of tan inverse 1? Pi by 4. Okay, so argument of this complex number will be pi by 4. In this way you can find the argument of any complex number. Now I am taking this complex number is in second quadrant. Let z is equal to minus 1 plus I. So this complex number will lie in second quadrant because real part is negative and imaginary part is positive. X coordinate is negative and y coordinate is positive. In second coordinate this complex number will lie, and it will be like this. Let this is O and this is point P, that is representing minus 1 plus I, and we have to find this much angle theta. So if any complex number is in second quadrant, so in that case what will be the principal value of theta? Principal value of theta will be pi minus tan inverse b upon a. So what is the value of a here? Value of a is equal to minus 1, value of b is equal to 1. So value of principal value of theta will be pi minus tan inverse 1 upon minus 1. So pi minus tan inverse minus 1. So this will be pi minus tan inverse 1, because mod of minus 1 is equal to 1. So tan inverse 1 is equal to pi by 4. Value of tan inverse 1 is pi by 4. So finally you will get 4 pi minus pi by 4. So 3 pi by 4. Principal value of theta will be 3 pi by 4, and argument of this complex number will be argument of minus 1 plus I is equal to 3 pi by 4. This is the principal value of this complex number. Understood? Now I am taking another situation. I will take this complex number in third coordinate and will try to find the argument of this complex number. Let z is equal to minus 1 minus I. Okay. Now what is the value of A here? Minus 1. And what is value of B is here? Minus 1. So if any complex number is in third coordinate, in that case principal value of theta will be minus pi plus tan inverse B upon A. So principal value of theta will be minus pi plus tan inverse minus 1 upon 1. So minus pi plus tan inverse minus 1 mod of minus 1. So minus pi plus tan inverse 1, because value of minus mod 1 is equal to 1. So minus pi, what is value of tan inverse 1? Pi by 4. So here you will get minus 4 pi plus pi by 4. So finally you will get minus 3 pi by 4. Minus 3 pi by 4 will be principal value of this complex number, or we can say that argument of minus 1 minus I is equal to minus 3 pi by 4. Okay. Now I will take example when any complex number is in fourth coordinate. So if any complex number is in fourth coordinate, so let it will be here, and let I am taking 1 minus I and this much angle. So let z is equal to 1 minus I. So what will be value of A here? 1. And what will be value of B? Minus 1. So principal value of theta will be, if any complex number is in fourth coordinate, theta is equal to minus tan inverse B upon A. So theta will be minus tan inverse. What is value of B? Minus 1 upon 1. So theta will be minus tan inverse mod of minus 1. So theta will be minus tan inverse 1. So theta will be minus tan inverse 1. What is value of tan inverse 1? Pi by 4. So principal value of theta will be pi by 4. It means argument of 1 minus I will be minus pi by 4. You can find the principal value of any complex number, whether it is in first coordinate, second coordinate, third coordinate and fourth coordinate as well. And you should take the principal value of theta between minus pi to pi. So student, this was all about the argument of complex number and how we can find the argument of any complex number. If you have any doubt, then you can ask in comment section.